Okay, we're back again and we're talking about a bunch of theorems that aren't too hard. We just need to draw some pictures. So it's telling us here that in a circle or congruent circle, so I just drew two circles to make it easiest. So they would be congruent circles. Congruent minor arcs have congruent central angles. So let's draw the picture. Let's put the center in here. So we're just going to go like this, okay? So we'll call it A, B, these and P here, okay? And then here we have to use different letters, so we'll use C and D and O. Okay, so what is it saying? It's saying if, it says if in a circle, congruent minor arcs have congruent circles, central angles. So if we have the arcs, so we're going to say the arcs are congruent. AB is congruent to CD. Then what can we say? The central angles are congruent. So angle APB is congruent to angle COD. Okay, that's all that's saying. Okay, now we have actually the converse of it in theorem 6.1.4. It says in a circle, congruent central angles have congruent arcs. So we're going to just do the same thing again. Okay, so A and B and P. And here we're going to do it with C and D and O. Oops, that's not going to, a little bit too small there. Okay, so here we're going to say, if the central angles, so if these angles right here are congruent, so angle APB is congruent to angle COD, then the arcs, arc AB is congruent to arc CD. Okay, so it's just the reverse. Okay, we have a similar thing going on here in this one, only we're talking about chords. So if we have congruent chords, that means congruent minor arcs. All right, so let's go ahead and do here, we'll call it AB, and I'm going to be generic about it, doesn't have to go through the diameter, and we'll call it CD. All right, so if the chords are congruent, so AB is congruent to CD with chords, so bar over the top, then they're arcs. So these chords are congruent, then the arcs are congruent. So arc AB, make sure you make it arcy looking, to arc CD. Okay, and then the other one is just reversed. Okay, so here we're going to say if we have the arcs congruent, okay, then we're going to have the chords congruent. Okay, oops, wrong mark there. Okay, so here we're starting off with, let's say, these arcs, okay? And then that says the chords are congruent, so A, B, C, D, okay? So if these are congruent, then the chords are congruent. All right, last problem for this page. Suppose that a circle is divided into 3 congruent arcs by points A, B, and C. What is the measure of each arc? And what type of figure results when A, B, and C are joined by line segments? Okay, so we're supposed to divide it into 3 equal pieces. So let's put A here. We'll put B here. And we'll put C here. When we divide it into 3 equal pieces, it looks like a peace sign here. Okay, so we're going to connect them. That's what it asks us to do. Okay, so it says, suppose that a circle is divided into 3 congruent arcs by point A, B, and C. What is the measure of each arc? Well, there are 3 arcs there, right? What's all the way around? 360. So wouldn't it have to be equally divided if they're all the same? It'd have to be 120. So we're going to say, since all of the arcs are congruent, they also have equal measure. So we know that there are 3 of them. So 3 times the measure of arc AB is going to equal 360 degrees, right? All the way around is 360 degrees. So if I divide by 3, that tells us what the measure of any one of those would be. So the measure of arc AB is equal to 120 degrees, okay? So that's also true for arc BC and arc AC, all 3 of them. And if we add them all up, we get 120. Okay, so what is the measure of each arc? We should really answer each arc measures 120 degrees. Okay, what type of figure results when we draw the line segments? Well, you probably have your guess as to what you think it looks like. Obviously, it's a triangle, but is it a special type of a triangle? Well, we know up above here it says congruent arcs have congruent chords. So if these arcs are congruent, if all those arcs are congruent, then that has to be congruent. The chords have to be congruent as well, according to this theorem here. Okay? So we would say by theorem 6.16, if the arcs are congruent, then they have congruent chords. Okay, so what is the shape? If all those chords are congruent, then it has to be an equilateral triangle. So the sides of the triangle are all congruent, which means it's an equilateral triangle. Okay, that's it for page 4.